We will talk about union. Unions are much similar to structures. They do have members, much like structures. You access members much like structures. All right, but there is a one distinction. Okay, that is, let's take it a simple example. Here, oh, 1 second. Let's take this example, definition 1.c. In here, I have declared a union with a tag name pixel underscore width, and it has a couple of members. All right, unsigned char, unsigned short, unsigned int, and let me just take out these two for now. All right, let me just comment them out. So it has only two members right now. All right, just forget that. Okay, it has only two members, and I've declared two members, and we are going to find out what would be the size of this union data type, right? The way it computes the size of a union data type is it computes the size of each member. In this case, we have two members. In this case, we have two members right here, which is 1 byte, and then we have unsigned short, which is 2 bytes. All right, so it takes the size of each member and finds the maximum of them. The max of this is 2. So the size of this data type union is, it computes the size of each member and then picks the maximum of them. Okay, the maximum is 1 and 2, we get 2. So let's compile this program. Compile this program and see. It says 2, like we talked, right? So that is how unions work. Union is, you can define as many members as possible, but the size is always, it computes the size of each member and picks the one that is larger. Okay, that is one distinction between the structures and union. All right, of course the rest of the definitions or distinctions comes because of this. The if you take the other problem with unions is, before we get into the other problems, let's take a couple of examples. Let's take this guy. Let's get the integer also right now. All right, So in this case, I'm going to I have added one int 4 bytes, and let's compute the size. It's 4. You see that? So going back to that and our whiteboard. So now I've included one more data type, which is 4 now. So you compute, oops, you compute individual size of members. So it's char is 1, short is 2, unsigned int is 4. So then if you pick maximum of them, then you get 4. So the size of this union with the 3 members in this case is 4. Now again let's bring the double. We have a double somewhere here, right? Okay. Now as you know, the size of this structure union with a double in it is is 8, because our double carries 8 bytes. So if you go back in here, if you compute that, it's 8 bytes now. So that is how this it works. Okay, and it doesn't matter if you have one more double. Let's say second, all right, or you have one more int. It doesn't matter how many fields you have, it always computes the size of each member and picks one which has the maximum size. Or let me make a copy of this. diff1.c2, let me just say version1.c, version1.c. Let's take this. So and now the question is, how do we store and read values stored in a union? Okay, in a union. We look into this now. How do we store and read? Okay. What really happens is, in our case, we have 3 members. Let's say our char is X, short is Y. These are the members of a union, all right? And our int is Z. Okay, so we have 3 members, and this union, let's talk about a data, simple data. Okay, this is a union. Oops. Okay, to store values, it's just like similar to structures. Data X equal to 10, data dot Y equal to 20, and data dot Z equal to 40. This is how you store data and read data, which is fine. But the problem with unions is right? When you say data dot x equal to 10, remember we have the size is only 4 bytes. So in this case, I will just erase these guys. All right. So we have 4 bytes. Are you with me? When you say data x equal to 10, data x is what? Char, right? So it writes 10 in that. Are you with me? Let's pretend this is hexadecimal. It's easier to write hexadecimal. So hexadecimal, let's say 50. All right. So it writes hexadecimal 50 here. 50, you know it what it is. It's 80, right? The integer is 80. Is it? Yeah. And so when you set data x equal to 50, which x is 50, it writes 50 in there. And when you say data.y, which is a short, let's say you write x is 6070. Remember, we have only one memory location, right, which is 4 bytes. So it has to deal with all this with just 4 bytes. So when you do 6070, it goes to the same memory location, overwrites what is in here. So in this case, it takes it away, right? 60 in here, and it writes 70 in here because it's 2 byte. This is a 2 byte. So he writes 2 bytes in that. See, in essence, the one you wrote, data x, is gone. All right. So you can write a simple program. You can write a simple program. Let me show it to you. Let's go back to the same. Let's rewind and call it as underscore data x y z. All right. Data. Okay. So let's data dot x equal to 50. I will print in, sorry, I'll print here data dot x equal, all right, I'll print in hexadecimal x, okay, and then I will write data y like we talked 6070. So data y, if you print it, right, if you print that, we said it will overwrite the 50. So let's see how. So how do you prove that? You go ahead and print data.x again. You'll know for sure about. Let's go ahead and print what happened to data.x, right? What happened to data.x? I expect you guys to practice on your own. Okay, so let's go ahead and compile it. GCC version 1.c. Now you print it. You see that I wrote data x is 50 first. All right. Initially I wrote 50. Then I wrote 60, 70. My 50 is gone because I printed data.x. It gave me 70 here. You see that? This is very important to understand because when you work in hardware related projects, they will manipulate the registers using unions and bit fields. So we'll talk about bit fields in the next video. All right, okay. So try to understand, write a program. Okay, now let's go back. Now I know my data x has been overwritten. I will now write data dot z equal x decimal 10, 20, 30, and 40. By the way, just to recap, when we say hexadecimal 50, this 0 takes 4 bits. This 5 takes 4 bits. So they both combine to make up for 1 byte. Okay? I hope you learned that in your introductory to computer science. That's why I'm skipping that. Okay. And now, so what will happen to my location? I would, my memory location now, which is the same, has become 10, 20, 30, and 40, literally wiping out this guy. It's overwritten. So how do you prove that? Go ahead and print it here. If you print the next statement, you would know. So let's go ahead. One zero, 20, 30, 40. Print. Oh, this is Z, sorry, right? Oh, Z. So I've written 4 bytes to Z location. And what happened to data.y? We need to figure that out, right? What happened to data.y? Yeah, so let's compile this. Before I close the file, let me tell you, I've written the data.c, a 4 bytes, and I've data.c is this. And so now I'm proving that data y has been overwritten. Okay. Okay. Now gcc a dot out. If you do it, oh, I'm sorry. Yeah, sorry. Correct. So data y, which is supposed to be 6070, has been taken over by 3040. You see that? I thought, oops, here you see that. When I wrote 10, 20, 30, 40, my y is been wiped out, and it prints 3040. So in essence, whatever you write into this memory location, the previous value that you wrote will be overwritten. Okay, so pay attention to that. Are you with me? So whatever you have written, or let me rephrase it, whenever you write into a data member a value, it replaces the old value. Okay, because they all point to the same memory location. They all point to the same memory location, and you can only write one member, thereby overwriting the old value. All right, the rest of unions are the same, which let me 1 second. Okay. So these are the code I've added to the PowerPoint. You can go over. Over here is a simple example. I've made a double array with the 10 elements. So what would be the size? So figure that out. All right. So this all, and here I've used typedef to define a structure called motorbike. I've defined another structure typedef called auto, and I've defined a union called vehicle, the two members called structures. So you see how now you can figure out the size of vehicle here. All right, write a program to find the size of vehicle. If you look at the members here, I have unsent char, unsent char, unsent char as 100 elements, and unsigned char is one more 100 elements, and unsigned int is 4. And here, if you look at here, I have only one array. So what would be the size of this vehicle? So write a program and you will know more about unions. Okay, so that concludes the union part. Okay.